All right, here is the circles test retake. All right, angle DAB is called N, which should give you a big old clue. In, sorry, exterior, had a brain fart there. Angle. We see this angle here is angle DAB, and it is on the exterior part of the circle. Okay, go ahead and try number 2. Number 3, what is the measure of angle NSQ? All right, well, to figure out NSQ, we can use this 176 and this 50 to find NSR, which is right there. And we're going to use the interior angles formula where we add the two arcs and then divide by 2. And that should give us 113. And then if this is 113 degrees, the angle that we need is a linear pair with the 113 degrees. So they're supplementary, so we could just subtract from 180, giving us 67 degrees for that missing angle that we need. Go ahead and try number 4. And number 5, arc AB. So arc AB has a central angle of 60 degrees. Circle O has a radius of 12 centimeters. What's the length of arc AB in terms of pi? So that would be theta times the circumference, which is pi times diameter, over 360. There are different variations of this formula, so that's just the one that I'm choosing to use. All right, theta is going to be the angle 60 degrees, and pi is just pi. The diameter is, well, this is the radius, so the diameter will be twice that, which is 24. And then 360 in the denominator. And we need our answer in terms of pi, so when you put this into your calculator, where's my calculator? So many things happening here. Hold on. Calculator. All right, so you can put this into your calculator. We'll put the 60. We're going to leave out the pi, and we're going to put the 24, and then at the bottom will be the 360. And that's going to give us 4. So our final answer is 4. And don't forget, we did not already calculate pi, so we're going to leave pi in the answer. Go ahead and try number 6. Number 7, what is the measure of arc? RS. So we're looking for the measure of arc, RS. We don't know anything except that RS is 2x plus 10, which means we need to solve for x. How are we going to solve for x? We have to use the other arcs to solve for x. So we're going to need to use all of this. So we're going to set up an equation with all of that. 2x plus 10, 3x plus 55, and 4x plus 25. And if you notice, they all add up to 360 because they all make up a full circle together. All right, let's go ahead and combine the like terms. We've got 2x, 3x, and 4x, which adds up to 9x. We've got 10, 10, 55, and 25, which add up to 90, if I'm not mistaken. And then the 360 remains the same for the moment. Now we're going to take away 90 on both sides. That'll leave us with 9x equals 270. Then we'll divide both sides by 9. That'll leave us with an x, and that's 30 for x. And now we're going to go ahead and plug that in for rs because that's what we are supposed to figure out. So that'd be 60 plus 10 is 70 degrees. All right, number 8. Number 9, the length of the radius of a circle is 6 centimeters. The arc of the sector measures, okay, sorry, I need pictures. Okay, well, maybe not that picture. There we go. All right, so here's our circle. The length of the radius is 6. And then, okay, and then the arc of a sector measures 72 degrees. So I'm gonna go ahead and make that 72 degrees. And that's the arc of a sector, which would be the same as the central angle anyway. So either way, it's 72 degrees. What's the area of the sector? Okay, so we need the area of this sector. And the area of a sector is theta times the area of a circle, pi r squared over 360. So that's going to be 72 for the theta. Again, theta is just the angle, times pi. Radius is 6. Square that 6. Put it over 360. And it says what is the best estimate? So that means our answer needs to be a decimal. So we can just put all of this into the calculator. Times pi, radius squared over 360. And we get 22.6. Okay. Go ahead and try number 10. And number 11, identify the circumference of the circle graph below in terms of pi units. Circumference equals 2 pi r. It doesn't matter which formula you pick, just pick one. And r is radius, and the radius of this circle is 1, 2, 3, 4, 5 units long. So that's 2 times pi times 5. And since we're putting this in pi units, we're just going to multiply the 2 and the 5, leaving the pi out of it because we want to write it in the answer. Go ahead and try number 12. Number 13, what is the radian of angle KOL if the circle has a radius of 2 meters? And I'm here to tell you, radians do not rely on the length of the radius to figure out how many radians something is, because the ratio is always going to be the same. So you can actually ignore that information. When we are going from degrees to radians, which is what we're trying to do here, we're going to multiply 90 degrees by pi over 180, and then you're just going to go from there. Now, in your calculator, what you can do is this. Instead of putting pi, you can just put a 1 at the top, get the fraction answer, and then just insert the pi in the numerator. So instead of putting 1 over 2, well, we can still put the 1 if you want, but it's going to be 1 times pi over 2, which is just pi over 2. Go ahead and try number 14. All right, number 15, we're going to write an equation to represent a circle with a center. This is going to be h, that's going to be k, and a circumference of 16 pi. All right, so here is the formula. X minus h squared plus y minus k squared equals r squared. Okay, so this is going to be x, and let me color code this. Not that it really matters, but maybe it helps. All right, so now I'm just going to duplicate it so that you can see what I'm doing. So I'm going to replace this h, this k, and this r. The h was -3. The k was +3. And the r, we don't know because it doesn't give us radius, it gives us circumference. So since circumference equals 16 pi, and we know that circumference equals pi diameter, and we know that the circumference is 16 pi, we can just say that 16 pi equals pi times the diameter. Now notice that pi is on both sides. They cancel out, okay? This is why. If we divide both sides by pi, they cancel out. So you're left with the fact that 16 is the diameter, which means half of that would be the radius. All right, let's clean it up. So we have x plus 3, right? Because of that double negative in there. Y minus 3, square that, and it's equals 64. Go ahead and try number 16. All right, number 17. Write the standard equation of a circle with this given center and radius. All right, so again, I didn't duplicate it. I'm about to be lazy. Sorry. Okay. So again, we're just going to take this and we're going to plug in what we got. So that's going to be h, that's going to be k, and of course that's r. So h is -3, k is 5, r is 3, and let's clean it up. Double negative means positive or plus, so it's going to be x plus 3 squared plus y minus 5 squared, and that's going to equal 9. When you square the 3, you get 9. Try number 18. And number 19, O is the center, T is a point of tangency, determine the value of X. So they said that if T is the point of tangency, that would make this a tangent line. And this has been determined as, this, oh Lord, O has been determined as the center, which means this is a radius. And there's a 90-degree angle between every radius. That is not how you spell radius, I'm so sorry. Okay, there's 90 degrees between each radius and the corresponding tangent line. So that means this is a right triangle. So this is a right triangle. Since this is a right triangle, we can find the measure of angle x by either subtracting 90 and 49, or you can use the triangle sum theorem, which I just did with just 90 because it's a 90-degree triangle. Or you can add 90 and 49 and subtract that from 180. Should have scooched that over. And then that should still give you 41. Regardless, the answer is 41 degrees. All right, go ahead and try number 20. All right, let's do the vocab. A segment whose endpoints are both on the circle. The key word here is segment, not line. It's not secant, it is chord. B, the distance around a circle or the perimeter of a circle. That is circumference. C, a chord that goes through the center of the circle. There's only one that does that. It's a diameter. That's not a C. D, a line that intersects a circle at 2 points. Keyword here is line. That would be secant line. E, a point in the middle of a circle that is equidistant from all the points of the circle. That is the center. F, a line that intersects a circle only at 1 point. That's a tangent line. Again, the keyword is line. G, an angle whose vertex, oh, I'm just kidding, an angle whose vertex is on a circle, on, and whose sides go through the circle. That would be an inscribed angle. H is the area between two radii and connecting the arc of the circle. It's going to be sector. I, an angle whose vertex is at the center of a circle and whose vertex, whose sides go through the circle. That's a central angle. And then of course J is 24. But an infinite set of points equidistant from a center is the circle. Voila.